I hope you all are well. So welcome back. Today we are going to discuss another important topic. Today again we are going to discuss the thing which is very important for solving the numerical problems in chemistry. Okay, so we are going to use that. In the previous video we have discussed about the significant figure. Now today we are going to see the use of the log, that how the log can make our calculation easier. Okay, so using log we are going to solve some numerical problems, or we are going to solve some problems, that multiplication and division basically, because we have to do lots of multiplication and division with very high and very low values, which is very difficult to do without calculators. So we are going to use log table for that. So I will be going to show you that how we can use it. Once in the previous video I have already discussed while solving the numerical problem of the density of unit cell. So if you haven't seen that video, you can just click on the I button and you can just go through that and see that how I have applied log and how I have applied log to solve all those problems. But there I haven't shown you that how we can use that log table. So today basically I am going to show you that how we can utilize the log table, okay, and how can we see the values in the log table. So this is our log table. So basically there are two tables here. One is log table and one is anti-log table, because both are required. I am going to show you the use and how to use them one by one. I have not drawn the full log table. Full log table will be different. It will be up to the greater values, but actually it's very difficult to draw the whole table here. So I have taken some values so that I can show you that how you can use it, okay, because values may be different, but the use you must know. If you understand how to use, then you can apply any value, okay. So one by one we are going to see. First we are going to see that how we use log, because when you are going to solve the numerical problems, log and anti-log both are going to be required. So one by one we are going to see that. So first we are going to see that how we can use the log table. So for that you have to see this value which I have put. The values which I have used here is basically I can use from this table, so that's why I have used these values only, but the calculation can be of any type, okay. And usually you are going to get the very tough or very difficult calculations, so you have to learn this way so that it will become easier for you, okay. Now suppose this type of the calculation is there, like 10 into 12 into 12 into 12 divided by 13 into 13 into 13, okay. Although it looks like little bit easy, but when you are going to get the questions, maybe the values may be higher. So in such case what you have to do, you have to consider all the values equivalent to x, okay. Any variable you can take, but I have used x. Then when you apply log on both sides, how you can apply log on both sides, that I have already made the video on that while solving the numericals on the density of unit cells. So again I am saying, if you want to see that, you just click on the I button and just go and see through that. Now when I will take log, then all the values will be like log 10 into 12 into 12 into 12 divided by 13 multiplied by 13 multiplied by 13 will be like that. Then the log x will be equivalent to all the multiples will become sum, like log 10 plus log 12 plus log 12 plus log 12. You can also write it as 3 log 12, because there are 3 log 12 are there, and whatever the things are in division, they will be acting as a subtracting, they will be going to be subtracted from the log part. So it will be like log 13 minus log 13 minus log 13, okay. We can also write it as 3 log 13. Now how we are going to see the table, that is very important. Now whenever you have to see the value of log, at least 2 digits are required. The table will be of like this, like if you can see the 2 digits are here, 10, 11, 12, 13, 14, 15, 16 up to 50 and 100 up to, and it can be there, 99 up to it can be there. Those two values you have to see for the third. What I want to say, like here it is log 10, okay. Now if there is only 2 digit here, then other value we can consider as 0 only, okay. That is log 10 into 0. So how we are going to see this value, that is we are going to see the value of log 10 into 0. So when I am going to see the value of log 10 into 0, it will be coming what? 0, 0, 0, 0. So what I will be writing here, 0 0 0 0. Okay, after that what I have to do, whatever the total number of digits are here, like here how many digits are there, 2, 1 and 0. From that we have to subtract 1, that is 2 digits are here, so 2 minus 1 become 1, and after that we put decimal, so it become 1.0000. okay, understand? Now again I will be showing you, like I have to see the value of log 12. So 2 digits are already 12. So third digit, if there is no third digit, if suppose it is 121, then we will say log 12 value we are going to see on 1. But if it is only 2 digits, then the other value we will be automatically considering as 0. So let's move to log 12. Now log 12 in 0, that is in 0, its value is 0792. Okay, so we'll be writing it here 0792. Okay, understand? After that, how many digits are there? 2. From that 2 you have to subtract 1. Okay, that is 2 minus 1, it become 1, and when you write 1, after that you will put decimal, so it become 1.0792. understand? It's easy. Now as other values are also log 12, so I am going to multiply all these values with 3 because it's going to be same. Okay, then it comes to log 13, that is minus log 13. So we move to the log 13, that is 13 value. Again there is no third digit, so we will be considering it as 0. So log 13 in 0 is 1139. So I will be putting the value as 1139, and there is only 2 digits, that is 13. So 2 minus 1 become 1. So it become 1.139 and multiplied with 3, because all are 13 here, so I am using it like that. So once the values are there, you are going to simply add them, and then whatever the value you will find, it will be coming equivalent to the x. Okay, so that is how you can find the log x value. Okay, so this is only I am showing that how to see the values in the log table. Okay, now after finding log x, you have to cancel the log and you have to take the anti-log also. How you can take anti-log, that I will be showing you in the later. But first we are going to see one more example. Now suppose this is the value. You can see 131 multiplied by 121 multiplied by 113 divided by 10 multiplied by 135. Now all these value I am considering equivalent to x. Okay, I'll be taking log x both side like that. So directly I am writing right now log 131 plus log 121 plus log 113. Okay, this we are applying the log will be applying like in addition. Whenever we are going to take the log of all value, then whatever the terms are in multiplication, they will be turned into the addition form, and others will be turning into, that is the one which is in the division will be turning into the subtractant form. So it becomes log 10 minus log 135. Okay, so like that it should be. Now if you have to see the log 131, so you have to consider only first 2 digit. So log 13 we have to consider only. Okay, and there is a third digit, that is 1. So what we will going to do, log 13 in 1. So log 13 in 1 is 1173. You can see that 1173. So I will be writing 1173. Now important term, how many digits are there? 3. So 3 minus 1, because whatever the number of digits are there, from that 1 should be subtracted. 3 minus 1 will be coming 2, and then you will put decimal, so it become 2.1173. Okay, one more example, log 121. So first 2 digit is 12, and in 1 you have to see log 121 means log 12 into 1, that is 0828. So you will be writing 0828, 3 digits are there, 3 minus 1 2, it become 2.088828. Then log 113. Log 113 means log 11, 2 digits and in 3. So it will be coming 0531. So we will be writing plus 0531, and 3 digits are there. 3 minus 1 become 2, that is 2.0531. Then log 10 is always going to be 1, no problem with that. Then minus log 135. Log 135, that is log 13 in 5. Okay, in 5, log 13 in 5. So its value is 1303. So I'll be writing it here 1303, and as there are 3 digits, 3 minus 1 become 2. Okay, so you can see you have to simply add and subtract here. That will become easier. Now I am taking this time, whatever the time I am taking, because I am showing you that how to do it. Once you are habitual of it, you will be doing it very fast and the calculation become much easier. Okay, because you know that in numerical problems lots of calculation which are going to be very difficult, you have to solve like that. So like that you can add all these things, and whatever the value will be coming, that will be coming equivalent to log x. Okay, after that, because you need to find x, you have to take the anti-log. When you take anti-log both sides, the log will be cancelled here, and you have to take the anti-log of that value which will be coming here. Okay, so how we are going to see the anti-log, that we are going to see now. Okay, so now we are going to see that how we are going to apply anti-log. So students, now we are going to see some examples where we have to use the anti-log. Now when you are going to use anti-log, when you suppose the calculation you have seen, we have find all the calculation like equivalent to log x. Suppose it is coming equivalent to log x. Now you want the value of x, so what you have to do, you have to take anti-log. Okay, so when you are going to take anti-log, the log will be cancelled on the left hand side, and on other side whatever the value is there, you have to take the anti-log of that. That is, it is coming like 0.012. Okay, now so I have used some value. Now here also again I have drawn this for the anti-log table for some value only, not for all, because it's become very difficult to show you like that. But you must understand how to see the value. Like for an anti-log table, you have to always use the values which are, you have to see the value of those only which are after decimals. Like here it is 0.012. Okay, so the way of going, the way you are going to see the values, that is going to be same as you have done in the log table also, but only those values you are going to see which are after decimal, and only 2 digits you are going to consider. Third digit, for third digit you have to see the value. Like here it is 0.012, so I am going to see the value of 0.01, 2 digits on third digit, that is 2. So 0.01 is this one, and its value in 2, so its value is coming 1028. Okay, you can see that it's coming 1028. So I will be writing it here 1028. Now what to do next? Whatever the value is before decimal, whatever the value is there, value I am saying, not digit, whatever the value is there before decimal, add 1 in it. Like it is 0, so I will add 0 plus 1. So what it will become? It will become 1. After that, means after that, if it is coming 1, you have to place the decimal counting from left in that value. Like it is 1, so after 1 place the decimal is going to come, it become 1.028, and that is going to be your value, that is the value of x. Okay, again one example I am going to show you. Like it is 2.037, and you have to find the value of x, so I am taking the anti-log both side. So anti-log of 2.037 I am going to take. So anti-log we are going to see from the values which are after decimal, that is 0.03. So I am going to see the value from 0.03 in 7, that is on the third digit. So it is coming 1089. You can see 0.037, that is 1089. So I am going to write 1089. Okay, now before decimal what is the value? Before decimal the value is 2. So I will be adding 1 in it. So here we have to add 1. So it becomes 2 plus 1, 3. So you have to place the decimal after 3. 1, 2, 3. So I will be putting the decimal here. So answer will be 108.9. So like that we can find the value of anti-log. One more example. Like it is 5.039. So I am using x equivalent to anti-log of 5.039. Okay. So We will be taking the antilog of 0.03 in 9. So the 0.03 is this and 9 is this. So this is coming. That is 1094. So I am writing 1094. Okay. Now before decimal the value is what? 5. 5 plus 1 become what? 6. So I will count 6. 1, 2, 3, 4. Only 4 is coming. So we have to put the decimal after 6. So we will be assuming 2 zeros from ourselves. Okay. From our side we will considering that much number of zeros and then we can put the decimal. So this is going to be our value of X. Okay. So that is how we find the value of antilog. One more example which is little bit unique, because suppose what happens, you are doing addition subtraction while taking the log. Okay. After addition subtraction, not necessary that every time the answer will be positive. Sometimes the answer can come negative also. Like in this case, you can see minus 4.3579. Now when such kind of situation will arise, what you will do? You will do minus 4 separate and minus 0.3579 separate. You will write like this. Okay. After that you will add plus 1 and minus 1 from your side. That you can do, because plus 1 and minus 1, that is going to be cancelled with each other. So we can write plus 1 and minus 1 from our side. Okay. Now minus 1 will be added to minus 4 and it become minus 5. And from plus 1 you will be subtracting the part, negative part, which is after decimal, that is 1 minus 0.3579. So it become what? It will now come positive. So that is 1, 2, 4, 6. Okay. So that is going to be the value. 0.64 6421. That is going to be the value. Now what you are going to do, you will be taking the antilog of this value. That is, you have to see the value of antilog only which is after decimal and which is in the positive form. So you understand what we did? First we divided the part which is negative in two form. That is, the value which is before decimal I have kept separate and the value which is after decimal I have kept separate. Then plus 1 and minus 1 we have added. Minus 1 will be added to minus 4 and become minus 5, while the value which is after decimal will be subtracted from so that it can come positive. Once it come positive, we will be seeing its value like that which we used to see. Okay. Here actually I have drawn till 0.03, so I cannot use that. Okay. So but you can see the value any other thing. Suppose instead of this value I am using another value. I am using the separate value because I cannot use the table otherwise, because the 0.64 is not given here. Otherwise in the antilog table it will be there. Okay. So I am using like suppose minus 5 and it become plus 0.032. Okay. Suppose it is like that. Now in this case 0.03 value you have to see in 2. So it become 1076. It is coming 1076. Now before decimal how many zeros are there? What is the value? That is 0. So you have to add like the same you used to do. 0 plus 1 become 1 and put the decimal here 1.076. Then whatever the value which is here in negative, okay, that is minus 5, that will be turning it as a 10 raised to the power of it. That is, it become 10 raised to the power minus 5 of that. So you can write the calculation like that. Okay, that is your value of X will be coming like that. Again I am saying I am not using this value. I have kept separate value to show you the calculation because I have written till 0.03, not 0.064. Okay. So that is how you can use the antilog table. Okay. One more example I am going to show. So let's see. Now we can see the two more examples where I am going to show you the subtraction method here. Like suppose if X is equivalent to the antilog of minus 5.99. Now what you can do, you will be writing it separately minus 5 and minus 5 and minus 0.99 separately. Okay. Then again you are going to add plus 1 and minus 1 here. Minus 1 will be added to minus 5, it become minus 6, and from 1 you are going to subtract 0.99 so that it can come positive. Okay. So when you subtract it, it become 0.01. Okay. So now what you have to do, you have to see the value of 0.01 into the third value. There is no third digit, so we can consider it to 0. 0.01 into 0 is 1023. You can see that 0.01 in 0 become 1023. So our value is 1023. Okay. Before decimal there is no value, it means 0. So 0 plus 1 become 1. So after 1 place you can put decimal. Whatever the value is in negative, you will make it as a power of tens in negative, that is 10 raised to power minus 6. So that is how you can calculate. One more example, if you have to take the anti-log here, okay, then minus 6, then minus 0.98, then then you have to add plus 1, minus 1, okay, minus 1 will be added to minus 6, become minus 7, then 1 will be going to subtract 0.98, so it become 0.02. So we have to see the anti-log of 0.02. 0.02 in 0 only because there is no other digit, so it become 1047. I am writing it here 1047. So before decimal there is no digit, so 0 plus 1 becomes 0, plus 1 1. So after 1 place we can put decimal. Then minus 7 is there, so it becomes 10 raised to power minus 7. So like that we can calculate. So basically students, what we have seen today, that how to see the log table, how to use the log table and solve our calculation. But remember, whenever you are using it in chemistry numericals, you are considering it against equivalent to a certain variable. When you consider it equivalent to the certain variable, then you have to take the first log. After log, you have to cancel the log on the left hand side, so you have to take anti-log, and then you have to apply these rules. Okay, so just go through it, it will make your calculation very easy. So it's going to be very helpful for you. Okay, and that is all for today. So subscribe my channel, like my channel, and keep watching. Goodbye.